Hey there, Mr. Sutton here with the IM3 Chapter 5 Quiz 1 Extra Practice Number 1 solutions on solving polynomials and synthetic division. To solve this polynomial equation, let's first see if we can take out common factors. Does not look like we can, and there's not 4 terms, so factoring by grouping is not going to work, but we do have the pattern of x to the 4th x squared constant. That is quadratic form. So we can actually factor this like a regular quadratic, only we'll use x squared instead of x when we break this up. So let's see here. This is actually going to be kind of tricky to factor as a quadratic because we have an a value out in front here that's not 1. So I'm going to use the AC method to help me here. So we have 2 times negative 12, a times c. That gives me an AC value of negative 24. So now I'm looking for factors of negative 24 that add up to 5. So we've got 1 and 24. That's not going to work. Neither does 2 and 12. How about 3 and 8? Well, if I had negative 3 and positive 8, that would do the trick. So I'm going to split this middle term up then into negative 3x squared plus 8x squared. And at this point, I do now have 4 terms, so I can use factoring by grouping. The first 2 terms, I can take out an x squared. That leaves me with 2x squared minus 3. For the next terms, I can take out a 4, leaving me with, again, 2x squared and minus 3. I can take 2x squared minus 3 out of everything, and now that leaves me with an x squared plus 4 in my other parentheses. And at this point, I'm just going to set each of these equal to 0 and solve. So for this first one here, if 2x squared minus 3 equals 0, then I can add 3 and divide by 2 to get 3 halves on the other side. But that's what x squared equals, not x. I still have to square root this. If I square root this, I've got a plus or minus, and then I have a plus or minus radical 3 over radical 2, which I can simplify by multiplying by radical 2 over itself. So that would give me radical 6 over 2 plus or minus that. Okay, so those are 2 of my solutions. Now I know from the fundamental theorem of algebra that my highest exponent here tells me how many possible solutions I should have. In fact, how many total solutions I should have if you factor in imaginaries and duplicates. So I should get 2 more out of this next branch here. So if x squared plus 4 equals 0, I can say x squared equals negative 4. Square rooting both sides. I'm taking the square root of a negative, so there's an I coming out of there. And the square root of 4 itself is 2, so this is going to be plus or minus 2i. To solve this problem, I first look to see if I can take a common factor out of everything. It doesn't look like I can, but I can try factoring by grouping since I've got 4 terms. So for these first 2, I can take out an x squared, leaving me with 5x minus 7. For the next 2, I can take out, looks like a negative 7 would do it. That leaves me with a 5x and a minus 7. Now I can factor 5x minus 7 out of all that, leaving me with x squared minus 7 in the other parentheses. And at this point, I'll set each of these equal to 0 and solve. So if 5x minus 7 equals 0, then I can add 7 and divide by 5 to get 7/5. And we could also say for this next branch here that x squared has to have a value of 7. So square rooting both sides, I'm going to get a plus or minus radical 7. To figure out the remainder from this division and all this other stuff, we have to use synthetic division. So let me start by writing the coefficients of my dividend here. That's going to be a 2 for the 2x cubed, a minus 5, a 19, and the negative 16. Since there were no missing terms, that means I have no placeholder zeros I have to worry about. Now for my box number, that's going to be whatever zeros out this divisor here, which is going to be positive 2, so 2 minus 2 equals 0. And then I'll leave a little space, draw a line, and I'll bring down my first coefficient. So I've got this box number getting multiplied by all these bottom numbers. So 2 times 2 gives me 4. Those numbers are going to go in this second row here. So we have a 4 underneath the negative 5 in the next column. And now I add these top 2 rows to get the rest of the bottom row numbers. So negative 5 plus 4 is giving us negative 1. 2 times negative 1, that gives us negative 2 up here. 19 plus negative 2 is 17. 2 times 17 is 34. And negative 16 plus 34, that's going to be 18. This last number here is our remainder of 18. Since that is not 0, that means that x minus 2 is not a factor of this larger polynomial. And for the quotient, that's all the other numbers down here that are not the remainder, starting one exponent lower than what we started with the dividend. So if you started with an x cubed, that means your quotient starts with an x squared. So this 2 really represents 2x squared. And this negative 1 really represents negative 1x. And then this 17 is just the constant plus 17. For this problem, let's use synthetic division to find all this information. So let's start with the coefficients of our dividend. We've got a 1 for the 1x to the 4th, followed by a 2. And after that, well, we're missing an x squared in here, so we need a placeholder 0 to hold that place. It's like having a 0x squared. And then we have a 40 for the 40x, and a 32. Box number on this one is going to be negative 4, because that zeroes out the x plus 4 here. So we leave some space, draw a line, bring down our first coefficient of 1. Negative 4 times 1, that gives me a negative 4 up here. 2 plus negative 4, that's how we're getting these bottom row numbers now, is adding these top two rows. 2 plus negative 4 is negative 2. And now we keep multiplying the box number by the bottom row numbers. So negative 4 times negative 2 is 8. 0 plus 8 is 8. Negative 4 times 8 is negative 32. 40 plus negative 32 is 8. Negative 4 times 8 is again negative 32. Hasn't changed in the last 10 seconds. But 32 plus negative 32, that is 0. So we have a remainder of 0, that last number down there. That tells us that since it's 0, that means yes, x plus 4 is a factor of our polynomial. And our quotient is going to be 1, using these numbers that are not the remainder. It's going to be 1, x to the 1 exponent lower than we started, so 1x to the 3rd power, followed by this negative 2x squared, plus 8x to the 1st power, plus 8, and that's it.